So I believe this is a fair definition for cycle diagrams. Moving forward in time, V1 moves over, V2 is appended to the right. V1, V2 move back over, V3 is appended to the right. For operations that are reversible in time, V1 is sent over, V2, V1 is appended with V2 to the left, and then V2, V1, V3 is returned back to point 2. So when the operation can move backwards and forwards in time, then the end on which the operation occurs alternates depending on which way the arrow is pointing. Also note, reversing the order of the values V2 and V1 should result in a flipping of the arrow and should not change the credence for that function being true. So if this is the case, that implies that chi1 and chi2 can switch places to give chi1 happening at a future state and a past state. Chi1 and chi2 should be reversible regardless, because the cycle diagram is the most basic operation that I'm assuming. And I'm also assuming recursion is allowed. Assuming a time reversible cycle diagram, define a cycle diagram to the nth power to equal the individual operations, both raised to the nth power or occurring n times. If the distance in time between the operations, if the amount of time the operations take to complete approaches 0 as n goes to infinity, then we say that the two mutually imply each other in an instant. Also, I'm guessing right here, but I think this equals, then this expression, which is it marching from chi1 to chi2 to chi1, with chi2 being a common point in the middle, equals chi1 to chi2 or chi2 to chi1, in that there's a point in time where chi1 runs into the future and chi2 runs into the past, and there is a point in time in which chi2 is from the past and runs into the future and chi1 runs into the past. It would alternate between these two possibilities with frequency r. What I want to consider next are sets. Some object is passed from a finite set back and forth. Eventually that set is going to run out of possibilities in terms of series that can be generated for some finite length string. Thus, if we count all finite strings of some length, we should be able to compute the maximum amount of time needed for a series to repeat. Once we determined the amount of time it takes for some object of the set to repeat, we can take the difference between that value and the value for the total number of possible ways for it to repeat, and that difference will be the entropy of the operation for the entropy for the operation should be the actual algorithm we're using, or the amount of times it takes for the loop to repeat before a unique set shows up again, versus the maximum amount of time. P stands for permutation, so permute n choose r equals the maximum number of cycles, and a equals the actual number of cycles, then the entropy, E of delta equals P of n take r minus a.